Hi there. Today we will talk about Django migrations, if they are friends or maybe not too much. But first, a couple of words about me. I'm Denny, I live in Italy and I'm working as front-end developer for fingerprint compliance services. But I'm a full-stack developer working with JavaScript, Python and a little bit of Go. Today we will talk about migrations in Django. Migrations are a way to propagate changes to models into a database schema. And in Django we have useful commands to handle migrations. So for example, make migrations, migrate, show migrations and SQL migrate. Let's see them one by one. So for example, make migrations creates new migrations for your apps. Its syntax can contain --empty in order to create an empty migration, and also you can customize the migration name for the file created, and you can use this command just for a specific application if you want to pass the parameter. So for example, if you want to create a model called the tweet with these fields, then you can save it in your models, in your main application. And then running main migrations creates a new file in main migrations initial.py containing the create model tweet. Inside the file, we can see the initial equal true, because this is the first migration. Then we can see a list of dependencies. In this case, we depend on the out user model, so that's the first dependency we need to use. And then a list of operations. For example, in this case, we have just a create model. This file is generated by Django automatically, so we don't need to change it in this case. Now, after creating the migration, we can update the database schema using migrate. The syntax is this one, so we can use a specific application label for the migration or a specific migration name if we want to just update to a specific migration. For example, in our case, we can run manage BI migrate on a new project and all migration will be applied. For example, in admin, out, content types, and so on. We can also roll back migrations to the first one, also before the first one, using the 0 parameter as migration name. All migration will be undone. Then we can move to a specific migration like this, so specifying the application and the migration name. Or if we just want to update to the latest migration, we just need to run migrate admin in this case, and all admin migrations will be applied. But how does it work under the hood? Well, we can inspect the Django migration table in our database. We can see it will contain 4 columns: ID, app, name, and applied. And in this table, we will see in the app the application name, of course, in name the migration name containing the number and the name specified by us or automatically added by Django. And in applied, we can see the time when the migration is applied to the database. There is a simple way to do this in order to just see if a specific migration has been applied or not, or also to see all migrations for a specific app. We can use show migrations. In our case, if we want to see all migrations for our main application, we can launch this command and the result is this one. The X stands for okay, this migration has already been applied to the database. Then, if we want to print the SQL statement for the name and migration, we can use SQL migrate as Django command, specifying an application label and a migration name, and the output will be this one. For example, for the first migration of main, we can see the create table, the alter table, and the creation of the index inside the migration. So what about we want to change a model, for example our model, extending the maximum length of the text of the tweet from 140 to 250 characters? Well, we just need to change the model in our files and then make a new migrations. Migration will be called with a nice default name, but we can customize it if we want. Then we can inspect the automatically created file containing the first initial migration in dependencies, and in operations we can see our alter field. If we want to see the underneath SQL, this is the command to run, so we can see the alter table inside the transaction, and then we can migrate our main in order to apply latest changes. Now the problem is, in the real world, what if we want to apply further changes? So for example, enabling tweet likes, adding for example a like model, enabling retweets, for example a new label field text and related tweet field. Oh yeah, I forgot the related name for like tweet field, so I had to add it. And keep in mind, I'd like to, during my development, I'd like to use atomic commits. So for each single change, I'd like to add a migration or a specific commit containing just this single change. So changes can be a lot, for example, enabling followers and so on. Each one of them will result in a migration. In this case, like tweet related, alter like tweet, and follow. We can just show migrations and apply them. Let's make another real-world example. For example, we need to add a new shop application with, for example, a customer model and shipping details. Then we need to add is premium field to the customer model. Then the business asks us to create a dedicated shipping address model in order to customize them and keep track of them. Then we need to migrate data to the new shipping addresses table with a new Django migration, and so on. So removing customer shipping fields and again other changes in the future running on. So increasing the length of shipping address, adding order model, adding created at to the order model, order line, customer type, choice field in order to select between free and premium for customer. Then we need to migrate the customer type from the flag to the choice field. Then remove the is premium field, and then again business asks for bronze, silver, gold and platinum customer types, so we need to add them, rename product quantity to quantity, just for clarification, and so on, so adding product model. This will end up in a lot of migrations, so yeah, I created this in the custom repository I will share at the end of this presentation, but yeah, they are pretty simple to use for development, because we can roll back to a specific migration, do the work and move on, and again, they are pretty easy. So we are happy, right? Well, not yet, because, well, in talking about performances in tests, it's not so nice and so easy? Well, as a disclaimer, timing may change from laptop to laptop, but in this case, timings are checked in my production machine, so keep in mind that. But for example, about performances, if we run tests in 20 applications like the one I created as an example in shop, running tests will take about 1 second. So that's great, right? What is the problem? Why this presentation? Well, if we time our tests, yeah, it's true, running test takes just 1 second. The problem is in creating the test database. So before running tests, a test database is created, and this takes 20 seconds to run. Yeah, 20 seconds, it's not so much, but the problem is it's 20 times more than the running tests. So that's not a good thing, in my opinion. And also, in our case, running tests on GitHub Actions ended up in spending a lot of time creating the database, more than running tests. So that was our problem, and I tried to solve it in different ways, spending a lot of time. And here's a quick recap. So first possible workaround in your local machine can be keeping the database, the test database. So this --keepdb preserve the test database between runs. If the database, of course, does not exist, then it will first be created, and migrations will also be applied in order to keep it up to date. So that's great. If you add more migration, they will be applied, and then for subsequent runs of your tests, the database is already there, so it's perfect. Well, there are a couple of pros and cons. For example, the pros are it saves 20 seconds for each test run after the first one, and that's great. The problem is that it's not so easy to configure in CI/CD because you need to cache your database somewhere, and that takes time too. So that wasn't our solution. Another solution, another workaround can be migrate equal false. By default is true. When you set this to false, migration won't run when creating the test database. This is similar to setting none as value in migration modules, but for all applications. So that's also a good solution. Single line change in your code base, and it doesn't run migration during tests. The problem is when launching your tests, it's like make migrations and migrate before running tests. So in our test repository, this will add 5 seconds more running the entire testing suite. So that was, yeah, a nice solution with a single line change, but that wasn't our best solution. What about performance? So a quick recap: keepdb, no time spent in creating database, but 1 second running tests. Migrate equal true, then 25 seconds, 5 seconds more. Nah, I don't like it. So running through the Django documentation, I found out squash migrations, and this will squash an existing set of migrations into a single new one, because I was thinking, well, if there are a lot of migrations, then we can just compress them into a single one and run it. So instead of creating, for example, 26 transactions for our 26 migrations for each application, then what about creating just a single transaction containing everything? Well, okay, a little bit time to spend, and let's try it. So I tried to launch our squash migrations to shop, trying to squash migrations from the first one to the 26th, and after a few seconds this has been the output, so created new squash migration. Well, there was a manual porting required, because if you have some kind of custom command, custom SQL or custom Python code to run, then that won't be migrated. So you need to copy paste that into the squashed migration file. I did that in the example repository, you can see later on. And then you just need to specify which is the code to run for executing that. So, inspecting the migration file, please keep in mind this slide is important for later on. Inspecting the migration file, we can see that a new value is there, replaces with the list of application and migration name that this specific migration will replace. So, reading through the documentation, the recommended process is squash migrations, keeping the old files, commit and release to production. Then wait until all systems are upgraded with the new release, and only then you can remove the old migration files, commit and do a second release. After that, you can transition the squashed migration to a normal migration using this. So deleting all migration files it replaces, updating all migrations that depend on the deleted migration to depend on the squashed migration instead. And last but not least, removing the replaces attribute in the squashed migration. Then you can commit, release, and everything will be perfect. Oh, in Django, starting from Django 4.1, you can use also manage PI migrate -- prune in order to remove prune references to deleted migrations. Only if you want or if you think you want to reuse the name of a deleted migration in the future. So this will remove references in the Django migrations table. Okay, now we have a single migration for every single application, of course. Then let's test the performances after squashing. Okay, well, a lot of time spent on this, but after squashing, again, creating the test database takes 20 seconds. So, that's not good, of course. So what's the point? Well, you can use squash migration only in order to move back from having several hundred migrations to just a few. That's the single reason you need to use squash migration. So for example, you have a big branch you are working on with a lot of migrations and you don't want to commit a lot of migration files. Okay, then you can squash them, commit them, and create your pull request with a single migration file. That's the only reason you can use squash migration. Yeah, I know, you wanted to speed up tests. Also, me was like that. So, do you really want to speed up database creations in tests? You need to recreate migrations from scratch and do a lot of manual tasks. So, are you ready? Let's start. So, first you need to annotate migrations for a specific app, like this. So, show migrations for your application. Store them somewhere in a file. Then you need to create a Python list with this format. So, replaces, of course, do you remember? And shop or application name and migration name in a long list. After this, you need to move migrations in a temporary directory. So your current migration will be removed from your application. And to check that, make sure that migrations are no longer there. You can run show migrations. Then recreate the first migration from scratch using a different name than the old migrations. So like this, --name init squashed. And it will create a single file containing everything for that specific application. Then you can copy-paste the replace list we created a moment ago in the migration file. You can restore all migration files. We moved into a temporary directory, we can move back in there. And then you need to ensure that all migrations are still there. So we show migrations, you need to see everything from 1 to 26 in our case. Then you can launch the migration command in order to apply this init squashed. And then again, back to post squash task. So commit and release, upgrade all system, remove all migration files, recommit and do a second release, and so on. Then everything should be perfect. What could possibly go wrong? Well, if you have migrations providing initial data, then you need to create a new migration file for that. Or even better, please use fixtures. Look at the documentation for that. You can use them in test and also application deploy, so they are perfect. Another problem could be circular dependencies, because, well, there could be a couple of circular dependency if you don't use a grain of salt in your development. So in order to resolve a circular dependency and break out one of the foreign key, you need to, of course, remove the foreign key, create the migration, and move the dependency on the other app with it. Then move back the foreign key and create the migration. So 2 migrations and you should resolve everything. Now it's time to test performances after recreating the migrations. And whoa, yeah, 5 seconds creating the test database because of this first single migration file, and of course 1 second creating the running tests. So instead of 21 seconds we moved to 6 seconds. Yeah, I think that's great. So thank you for your time, and here it is, your link to the sample repository. You can see in the Django settings migrate branch the change I did just for the single line of migrate equal false. Then in the other branch and in this pull request you can see squashing migration. So changes for squashing the migrations. And in the last branch, recreating migrations, then you can see the last solution I found for moving from 21 seconds to 6, 7. And that's great. Thank you very much for your time. If you have questions, I'm here, or you can contact me everywhere you want. Here's my details. Thank you very much again, and bye.